So, we need to know something about C. So, I am not sure how many of you know C. So, let me just recap. Pointer is what I want to discuss a bit. So, the first program is very simple one, hello world. So, we have this std, well this is done, stdio.h. So, this you can put by without any, well you need to do stdio.h all the time, because print will be coming from input output standard library, and standard lib also is okay to keep. So, you always have one main program which has print and return. Okay. So, this is my code. Printf is pretty clumsy in C, but we will have to live with it. So, I would recommend that use C, don't C++ also is possible to write it, but stick to, I am sticking right now to C, because then if you use C++, then you need to change this library, it has a different name, IOStream. So, usual C codes are compiled with GCC, right, GNU compiler, which is available in Colab. So, you can say, by the way, typically the name will hello.c, right. So, GCC hello.c, and you can create an object file -o hello. This is a thing written in executable code in Colab, and after that we can just say hello dot hello. So, this is how I execute my C programs. Okay, first compile it, get executable file which is hello, and run it. But in CUDA codes are not written in C, because CUDA by the way, CUDA is basically C code with some additional features like MPI features, sorry, I won't say MPI like MPI library is there, similarly there is a CUDA library. So, but you need to write, they are labeled differently, they are called .cu, .CUDA, and on Colab you can use another compiler called NVCC, NVIDIA compiler, NV for NVIDIA compiler, C compiler, NVCC. So, so GCC cannot create a CUDA code, cannot compile a CUDA code. CUDA data transfer, CUDA array allocation, it can't do it, but NVCC can. Okay. So, if I want to run a CUDA code, then here is a NVCC CUDA hello.cu -o hello, and so basically you don't use GCC, use NVCC, okay, which is available in Colab. In Colab you need to also do one more thing which I will tell you in the next class by one snippet. So, you need to use a GPU when you select your device. Okay. So, runtime there is a way to select a device, use a GPU, and you get one GPU. Okay. I am getting basically Tesla. Okay. Tesla GPU is what is coming, not A100, but Tesla GPU is available for free. But you can test your code. C codes have conditional statement, loops, functions, and all. Well, C is very powerful language, it can do all that stuff, not objects, but it can do all this. For CUDA programming I need pointers. Why pointers? Because I will create, I do not create a variables, right. I mean, I will basically create pointers to variables for what resides in GPU. Okay. So, just imagine that this is my CPU memory and this is my GPU memory. My array will sit here, but I am controlling from CPU. So, what do I need? I do not have array, I will say I have the pointer to this array. Okay. So, that is how pointers are very critical for GPUs, you cannot manage without pointers. So, code will have lot of stars, okay. Pointers are stars. So, actually this is not thing to say, they are not, they are declared in CPU, okay, that is correct, allocated in GPU, arrays are allocated in GPU, this correct statement, sorry, are declared. So, they must be pointers in CPU, otherwise it does not have, I mean it cannot have any control, right. I mean I lost address, that guy is gone elsewhere, that is it, you can't control. You need to have the address of location, and then you say, well, you do this, you do that, and get the data, all that. And CPU doing the command, no? So this is not, CPU is not sitting idle. So pointers, I don't know. I mean, I was pretty. It doesn't sink in very well. Okay, that's why I would say even now I make mistakes with pointers. So this picture is, I believe, is a good picture. So variable x, everybody knows variable, no? So that's what variable x. So x int x equal to 10. So you need to declare the type of each variable, no? I mean, see. So this variable name is x, and it is has value 10. So if you go to the location, then I get the number 10 inside, number 10 is sitting in binary form, but I need to know the address of that. Okay. In C, which is for operating system, would no need to know the address. Fortran didn't care about address. Okay. I just need to know the variable with the programmer. So how do I get the address? So you need to create a pointer first. They are special variables which do not, they are not called integers, in fact they are called pointers. These pointers are, they hold only address. They are different variables, okay, in many sense, and they are declared as int star. And if I write int star p, then p is a pointer, it is not an integer. And how do I get address of a variable x? So, say p equal to this ampersand x. So, ampersand is an operator, is like plus operator or any operator. Ampersand operator which acts on x and gives you the address. So, p will give you, p will have a integer, well it has a address, and this address happen to be this number, okay. So, address are typically big, it has gigabytes of data. So, every byte has an address, okay. So, p is, by the p is also stored somewhere, okay. So, this address is stored in a variable, okay, and in a location, address is stored in at a location, and the location has a different address. This address is not same as p. So, there is a x which has an address, the pointer p which is address of x, and stored, p is also stored somewhere, okay. So, p is what is address. For you, just think the p is an address. So, let us write a simple code which has these features. So, main, inside main I have int x equal to 10, I declare a pointer, ptr is a pointer, it is not integer, is a pointer, and the pointer is getting the address x. These two lines could have been combined into one line like this, but let us keep it separate. So, pointer is the address of x. You can use these two lines to do that task. Now, I print x, no problem, x is printed here, x, and by the percentage d is for saying that these variables are address. That is why in C++ you do not need all this percentage d, percentage f or all that, but in C you need it, and C output for you can just copy it like this for the project, but some of you are probably expert, okay. I always get mixed up, print is one, scan is even worse. Scan is, very often I used to make mistakes with scan. So, printf is printing x, but with pointer, suppose I say, well, I give the pointer and print x, what should I do? So, there is an operation called star, operator called star. Star acts on pointer and gives you the value stored in pointer. This star is also, this one, but this is not an operator, int star is not an operator, but this is an operator acting on pointer, is giving you the content at ptr, what is stored in ptr, and that is x. So, this is ptr x star ptr, okay, which is will be x. So, this should print x, both of that should be 2 prints and they will be the value of x. If I want to get the pointer, what should I do? Well, I can just print pointer as ptr, do not put a star there, okay, that will be x. ptr is an address, or this stuff ampersand x will give the address. So, I can get the address in 2 ways, either by ptr or by ampersand x. So, if I execute this, I get for this print 1010 should be, and this line will print for me a pointer which is this value, okay, is the address of x, or ampersand x will also print with this. Okay. This for every variable C offers this, not only for integer, for float, for character, they stored somewhere and you can do it. But in CUDA I am going to use arrays, and array as a pointer is another tricky thing which C has it. You may know that C is a language for, it is both higher level as well as lower level language, right. People know this, or C can do many things which at a byte level, at a bit level. For operating, when someone want to write operating system, we need to have this capability, otherwise you can't write operating system. You need to manipulate address and all that. If you should, I mean, some of you, if you are interested in computing, you should read how Unix was born. Okay. Unix was born in Bell Labs, and its really fantastic ideas came while designing Unix. But I have no time for this, but Unix you should read in Wikipedia itself, you will find good discussion. So, you create an array A, which has right now I have 5 elements, and their addresses, well, I mean I can get the value at A0, A1 square bracket, is 1D array, A0, A1, A2, A3, A4. But when you say A, just A is a pointer to this first entry. First element is A0 is a pointer. So, A in fact is stored in a consecutive array locations, memory locations. Okay. In fact, it starts from this address. For my example, when I did this address, start from this example, this will be integer. So, 4 bytes later. So, these are how they are stored. When I say A, then it is a pointer to this. A is basically, value of A is this, or you can get a pointer to A0. A0 is a number, right. A0 is in fact right now is number 1. If I say what is pointer to A0, that will be the same number. And once I have the pointer, then I can get the content of the pointer, right. How do I get a content of pointer? Star. So, star ptr will give me 1, okay, content inside. Star ptr plus 1, what will it do? It will give me 2, because it is, well, pointer is not incrementing the bytes, it is incrementing the word for integer. So, it is pointer plus 1 will give me 2 and so on. Okay. So, in fact, a lot of C programs have this, your array is not address retrieved as A1, A2, A3, A4, they are retrieved like this, and it is very confusing. What is the star doing? You know, why are you adding this? But many CUDA programs may have this kind of stuff, but I mean these are something we need to know. So, this is a simple example which is here illustrated here. So, I have array A which is 5 entries. I create a, by the way, sometimes int star ptr and int star ptr is same, okay. It's compilation wise no problem, but I prefer to write like this. So, it is telling the ptr is a pointer, okay. It is not a star pointer may be confused with a content of pointer, it is not addressing like that. I can also make a remark, the C++ is better to read. You can do all this stuff, but you did not do this stuff with arrays. So, let us print a pointer Okay, this will so this pointer is a pointer pointer type variable and equal to a. I said a is not content of a is not integer 1 2 3 like that. Okay, a is the address of the first location of the array. So a is a pointer which is gets now PTR value gets the value of this address. Is that clear? This what does this line mean? A is not an array, a is address, and that is the same value as PTR now, or PTR has the same value as a. So a PTR and PTR of a0. So I write these three stuff a PTR and ampersand a0. Ampersand is address, right? So a0 is a number. So ampersand a0 will give me the address where a0 is stored, which is this. So the first line will give me 3 values or print 3 values, and they are all address and the same address. Okay. So address, address, address. So we can get the address of the first entry by 3 ways. Next, I can print a0 as, I mean, this is value at a0, which is this 1, or star PTR, both of them will give you what? 1, right. So these are 2, 1 and 1, but what I put star PTR plus 1, I will get the second value, which is 2. Star PTR plus 3 will give me fourth value. So it will give me 4 and like that. Okay. So this is the illustration of what array is. Okay. So let us end here. I am right on dot, and I will cover 2D arrays, which is also a tricky part in C, and then we will go to CUDA programming.